Okay, today's aim is understanding dilations. Before we start getting into dilations, we have to first define some key terms, and the first one is defining what a dilation is. So, a dilation is a transformation in which a polygon is enlarged or reduced. And this is important because when we think about something being dilated, we think about something being enlarged. But in actuality, when we're talking about dilations in transformation geometry, we're talking about either enlargements or reductions. It can be either one or the two. By the way, all this needs to be written down in your notes. You need to have all these definitions down, and I'll let you know what other screens need to be written down in the notes section of your binder. Okay, so a dilation is a transformation in which a polygon is either enlarged or reduced. The second term we have to talk about is the scale factor. Because if something is being enlarged, then the scale factor is going to be a number greater than 1. If something is going to be reduced, then its scale factor is going to be less than 1. And we'll talk about that in more detail in the next screen. But a scale factor is the amount by which a figure grows or shrinks. So if it grows, it's an enlargement. If it shrinks, it's a reduction. Whether it grows or it shrinks, it's still considered a dilation. This needs to be written down. If you need to put your player on pause, do so, and then hit play to resume. The third term you need to have down in your notes is the center of dilation. This is a key component of dilations. So a center of dilation is a constant point on a surface from which all other points are either enlarged or compressed. So these three need to be in your notes, and each one of them, scale factor and center of dilation, will be clearer once we discuss them in more detail. Okay, so what type of dilations are you all familiar with? And the dilation that is most common for people is the dilation of the pupil. So the pupil is actually a hole in the eye. It is surrounded by the iris. The iris is the muscle. And in normal light, this is the way the pupil looks. So you have the iris, which is 12 millimeters long, and the diameter of the pupil is going to be about 2 millimeters. So from one end to the other of the pupil, that's going to be 2 millimeters long. In dim light or no light at all, the pupil dilates. The pupil gets larger, and as you can tell, in low light situations, your pupil is actually 8 millimeters long. So we have normal light, where the pupil is only 2 millimeters long, and in dim light, the pupil is 8 millimeters long. The iris stays the same. The iris is still 12 millimeters in diameter. So the question is, what is the ratio of the dilated pupil to the undilated pupil? Well, before we start talking about the ratio of the dilated to the undilated, we first have to talk about what a ratio is. So this is a refresher from algebra. So let's take this down. A ratio is a comparison of two quantities by division. That's all it is. You can write a ratio of two numbers a and b in three different ways. You can write it as a fraction, which is what you're most accustomed to, a to b. You can write it with a colon b, or you can write it out in plain English, a to b. Usually express a and b in the same unit and write the ratio in simplest form. So we would say millimeters to millimeters, or inches to inches, or yards to yards, or miles to miles. Okay, so let's write this definition down. Definition of a ratio. This needs to be in your notes. And when we talk about similarity a little later on, ratio will become clearer. So they're asking, what is the ratio of the dilated to the undilated? Well, the dilated pupil to the undilated pupil. Well, the dilated pupil is this one, the one that's enlarged. So it looks like the dilated pupil is 8 millimeters in diameter. The undilated pupil, that's the pupil in normal light, is 2 millimeters. So we would say the dilated to the undilated, the dilated, which is 8 millimeters, to the 2 millimeters, is 8 to 2, or you can write it as 8 to 2. And we usually like to reduce our fractions, so we can also write this as 4 to 1, or we can write this as 4 to 1, like that. Okay, so the ratio of the dilated pupil to the undilated pupil is 4 to 1. Okay, so here's an important component to dilations, and that is the scale factor. And we talked a little bit about scale factor. We defined the scale factor over here, the amount by which a figure grows or shrinks. So the scale factor can be used to make a figure larger, or smaller, and the two figures are similar to each other. So what does it mean for two polygons to be similar? That is the question. What does it mean when two polygons are similar? So we'll talk in more detail about similarity, but the key concept needs to be down in your notes. So let's take this down. If you need to put your player on pause, go right ahead, but please take this definition down and everything that is on the screen. If you'd like to listen to this first and then take it down, perfectly fine. So similar figures have the same shape but not necessarily the same size. Okay, and you can abbreviate similarity or is similar to with the tilde symbol. If you remember when we talked about congruence, we used a symbol, and the symbol for congruence was the tilde with the equal sign underneath. That's congruence. Similarity is just the tilde sign. So we want to say two figures are similar. We use the two figures A, B, C, D is similar to G, H, I, J. So let's take this definition down. Two polygons are similar if, and this is very important, there are two components. Number one, the corresponding angles are congruent, and number two, if the lengths of the corresponding sides are proportional. So let's take a look at this figure. So we have ABCD, or ABCD, and ABCD is clearly being enlarged to arrive at GHIJ. Now if you can actually see that, because if I took this figure and I actually enlarged it, you'll notice that they are the same size. I mean, not the same size, they are the same ratio. In other words, AB is the same ratio to GH as BC is to HI, as CD is to IJ, as DA is to JG. And you can see that right over here. Number one, the first requirement is that the corresponding angles are congruent. Notice the corresponding angles are congruent. Check, that's true. And the corresponding sides are proportional. AB is to GH, AB is to GH, as BC is to HI, BC is to HI, as CD is to IJ, as CD is to IJ, as AD is to GJ. They're clearly not the same size, but they are proportional. And you saw that when I took this first figure, right, our first figure, and I basically enlarged it, and the sides indeed are proportional. This belongs in your notes. Please take it down. If you need to put your player on pause, do so, and then hit play to resume. Okay, next. A dilation is an enlargement if the scale factor is greater than 1. Remember, a scale factor can be either greater than 1 or less than 1. If the scale factor is greater than 1, then it's an enlargement. If the scale factor is between 0 and 1, then it's a reduction. So, here are two examples. Here, my center of dilation, if you remember, the center of dilation is what? The center of dilation is a constant point on a surface from which all other points are either enlarged or compressed. So my center of dilation here is A. The center of dilation here is C in the second figure. So it says, for each figure above, is it a reduction or an enlargement, and what is the scale factor? So let's first understand which is the original figure and which is the enlarged figure, or which is the reduced figure. And let's talk in terms of preimage and image. The preimage is the black figure. That's the preimage. That's before I apply the dilation. The blue figure is the image. That is after I apply the dilation. So preimage is before, image is after. So what do we have here? It says for each figure above, is it a reduction or an enlargement, and what is the scale factor? But let's see. The preimage is the black figure, A, B, C, D. So that's my preimage. What is the image after the dilation? It's A prime, B prime, C prime, D prime. How do I find what my dilation factor is, the factor by which I'm dilating this? It's clear to us that the dilation factor is 2 because D prime C prime is twice of DC. How would I be able to set this up so that I'll always get the dilation factor correct? Here's what we do. I want to find the dilation factor. Whenever I have something I don't know what it is, I use a variable. Typically I use x. So I'm going to say 2 times x is equal to 4. And I want to solve for x. In other words, 2 is my length of my original side DC. I want to find out what did I need to multiply 2 by to get 4. That is going to be my dilation factor. So what do I do to solve for x? Well, simply divide both sides by 2, right? So that means x is equal to 2. So number 1, I can see it's an enlargement. And number 2, I can see that my dilation factor is nothing other than 2. So there is the answer to my question. So the dilation, first of all, it is an enlargement. The center is A, that's the center of my dilation, and the scale factor is 2. How about the second case? Okay, so here what I have is the original side EH is 8, and the dilated side is E prime H prime. Now clearly I am reducing this, so it's definitely a reduction. No question about that. I'm going from EH, which is 8, to E prime H prime, which is 2. What is the center? What is the center of dilation? Well, that's C. What is the scale factor? Well, again, I don't know what my scale factor is, so I'm going to call it X. And what we're saying is 8 times X is equal to 2. I've got to solve for X, so I divide both sides by 8. Well, these guys cancel out. X is equal to 2 over 8, which is the same thing as 1 over 4. So my scale factor is 1/4. So that is the answer to my question, mystery solved, and it is definitely a reduction, and my scale factor is 1/4. Okay, this is essential to understanding whether I'm enlarging or reducing something, and that is the scale factor. Okay, so let's take an example. It's saying multiple choice. Triangle x prime, t prime, r prime is a dilation image of xtr. So xtr is my pre-image, x prime, t prime, r prime is my image. The center of dilation is x. Very nice. Is the dilation an enlargement or reduction? That's the first question. Then what is the scale factor of the dilation? Well, let's see. So I'm going from xt to x prime, t prime. So I'm going from xt, which is, let's do this in a different color. I'm going from xt, which is this right over here, to x prime, t prime, which is this guy right over here. I'm going from 4 to, well, that's the question. From 4 to what? Here's something to keep in mind. This is my center of dilation, which is this point over here, which is both x and x prime. So xt is equal to 4. X prime t prime is not 8. It's 4 plus 8, which is 12. Remember, x prime t prime is this whole thing right over here, which is 4 plus 8, which altogether is 12. So first of all, I'm going from the black to the blue. The black is the pre-image, the blue is the image. So I'm definitely doing an enlargement. So these guys are definitely wrong. So now what is my scale factor? Well, let's see. What do I need to multiply 4 by to get 12, right? So in other words, what do I need to multiply 4 by to get 12? If you set this up algebraically, you will always get the right answer. Divide both sides by 4 to solve for x, and x is equal to 3. So my answer is B. If you need to take this example down, please do so. It's important. Next. So here's another question. What are the images of the vertices of triangle PZG? Remember, PZG is the pre-image for a dilation with a center of 0, 0 and a scale factor of 2. Graph the image. So, first of all, is this a reduction or an enlargement? And justify your answer. Well, what is the scale factor? The scale factor is 2. So if the scale factor is 2, what does that mean? Well, if the scale factor is greater than 1, it's an enlargement. So it's definitely an enlargement. It's definitely not a reduction. Then the question is, what are the coordinates of my new figure going to be? Well, what we need to do is we take each of these coordinates and we multiply them by 2. So I'm going to take 2 times p, and p is 2, 0. So that's 2 times 2, which is 4, and 2 times 0, which is 0. So this is my p prime. So p prime is 4, 0. Next, z. my scale factor is 2, so I'm going to take 2. Let's make that look, how about this? 2 times z, and z is what? Z is negative 3, 1. So 2 times negative 3 is negative 6, and 2 times 1 is 2. So z prime is going to be negative 6, 2. So this is going to be z prime. Let's actually note this here. So this is p prime. This is z prime. And finally, I have g, which is 0 minus 2. So my scale factor is 2, so 2 times g, well, g is 0 minus 2, so my g prime is going to be 2 times 0, which is 0, and 2 times negative 2, which is negative 4. And it's going to be hard for me to graph it here, but 0, 1, 2, 3, it's going to be somewhere down here. So this is going to be my g prime. And if I were going to graph this, it would look like this. And that would be my graphed image. Okay, next. Try to do this one on your own. So what are the images of the vertices of triangle PZG, exactly the same figure, for a dilation with a center of 0, 0, so that's a point of origin, and a scale factor of 1/2. Put your player on pause, try to get the coordinates, you don't have to graph it, try to get the coordinates of triangle P prime, Z prime, G prime, the image of PZG after the dilation with a scale factor of 2, and then hit play to resume when you want to see the answer. Okay, so once again, I'm going to take my scale factor, which is 1/2, I'm going to multiply it by each of these coordinates. So I have 1/2 times z, which is going to be 1/2 times minus 3, which is minus 3/2, or minus 1.5, and 1/2 times 1, which is 1/2. So this is going to be z prime. This is going to be my z prime. What about point P? Well, my scale factor is 1/2, so I have 1/2 times point P, which is going to be 1/2 times 2, which is 1, and 1/2 times 0, which is 0. So this is going to be my P prime. And finally, I have 1/2 times G. And what are the coordinates for G? Well, 0. 1/2 times 0 is 0. And that's supposed to be a 0. There we go. And 1/2 times minus 2, which is minus 1. So this is going to be my G prime. Good. All right, let's try another one. So triangle PZG has vertices 2, 0, minus 1, 1/2, and 1, minus 2. What are the coordinates of the image of P for a dilation with a center of 0, 0, and a scale factor of 3? So again, it's asking me what are the coordinates of the image of P. It really doesn't care about the other coordinates. So what do I do? I look at P, which is 2, 0. I have a scale factor of 3, so I'm going to do 3 times P, which is 3 times 2, which is 6, and 3 times 0, which is 0. So my answer is going to be B. Okay, let's take a look at this one. So it says J prime, K prime, L prime, M prime is a dilation of the image of JKLM. So notice how the blue is a dilation of the black. So first order of business is this a reduction? Is this an enlargement? Well, clearly I'm going from the black, which is larger, to the blue, which is smaller. So I'm definitely going to have a reduction. So it says, is the dilation of an enlargement or reduction? Clearly it is a reduction. I'm going from the black, the pre-image, to the blue, which is the image. What is the scale factor of the dilation? Now, notice how they're not giving you any numbers here, but they are telling you on a coordinate plane that KL, and let's make this, let's do this in blue. Is this blue? Let's see if this is blue. No, it's green. So I have K prime L prime, which is 2. Right? I'm going from 2. I'm multiplying that by some scale factor, and that's going to give me, oh actually no, sorry about that. I'm going the opposite way. Let's strike that. This is 2, and the original figure is KL, which is 1, 2, 3, 4. So this is 4. So I'm going from 4 to 2. So 4 times what scale factor is equal to 2? Again, you divide both sides by 2, and you get x is equal to 1. 4 times x equal to 2. So divide both sides by, divide both sides by 4. Let's scratch that completely, and let's start over. So I'm going from 4. 4 times a certain scale factor is equal to 2. You divide both sides by 4. Most of you are thinking, what is he dividing by 2 for? And you're absolutely right. I divide both sides by 4, and you get x is equal to 1/2. So my scale factor is going to be 1/2. It's a reduction, and my scale factor is 1/2. So, and they tell you, look at the coordinates of JKLM. Also look at which quadrilateral is the dilation of which. Clearly the blue is a dilation of the black. Remember, a dilation could be either a reduction or enlargement. In this case, it is definitely a reduction. Okay, take this example down if you'd like, and take a look at your homework, and we'll see you on the other side.